Alright, this is another video for lesson 3.6, video number 3. We want to prove that our sequence for x of n is equal to 1 over n for n equaling 1, 2, and so on, infinite. Sequence is a Cauchy sequence, and we're going to abbreviate that CS. Alright, so we start off by writing this as, I'll use blue, as our sequence x of n is a Cauchy sequence if for all epsilon greater than 0 there exists a n that is an element of the positive integers, and we want to choose n, uppercase N, but we don't know what that number is, so we're going to have to work some scratch work out to find that. Then we can go back and write our proof, where our sequence lowercase n and sequence lowercase m are elements of not the natural set of natural numbers, and our lowercase n is greater than our number n that we're going to find, and m is greater than our uppercase n. So this uppercase n is different than the set of natural numbers. This is our number from here, whereas natural numbers are counting numbers like 1, 2, 3, 4, and so on, which is what we're using up here for natural numbers. And so this implies, this arrow means this implies the absolute value of x of n minus x of m is less than epsilon. Okay, so we want to work our scratch workout. So this is our scratch work. Okay, so we're using the scratch work to find what our n is, and then we can go back and write our proof. So we start with the absolute value of x of n minus x of m is less than epsilon. And so x of n is 1 over n. So this will be the absolute value of 1 over n. And x of m, so here we're going to put m here for 1 over m. And so from there, we can go ahead and split this to 1 over n plus negative 1 over m. And from there, we, through our triangle theorem, where we had our vectors. We're going to go back over this again. Here we had the magnitude of A and the magnitude of vector B. Well, both of these are going to be the magnitude of A plus B. So this side is going to be less, A plus B is going to be less than or equal to the magnitude of A plus either one of, this side here is going to be less than the sum of the other two sides. So that's what we're doing here. So this is going to be less than or equal to absolute value of 1 over n plus absolute value of negative 1 over m. And since this is absolute value, then that's going to be just 1 over n plus, we can drop the negative because the absolute value is going to make it positive anyways. Okay, so from here, since these are going to be positive, we can drop the absolute values and write this as 1 over n plus 1 over m. Okay, since we want this all to be less than epsilon, okay, these are all less than epsilon, right? We can definitely say that if 1 over n plus 1 over m is less than epsilon, then just 1 over n by itself is definitely less than epsilon. And so since we're writing both of these, we're saying that 1 over n is less than epsilon over 2. Because then we could say 1 over n is less than epsilon over 2, and this is 1 over m is less than epsilon over 2. So both of these together would be less than epsilon. So from here, if we could either multiply n, multiply 2, and then divide by epsilon, or we could just apply the reciprocal n, and when we do that, we have to switch the inequality sign. So this will be 2 over epsilon. Well, why does that work? Because if we multiplied n to both sides, right, we would get, the n's would cancel, and we get 1 is less than epsilon times n over 2, and then multiply 2 to both sides, and so the 2's cancel, and then divide epsilon, and that's how we get 2 over epsilon is less than n. So we can do this all in one step by just applying the reciprocal and changing the inequality sign. But we can do the same thing for m. 1 over m is less than epsilon over 2. Apply the reciprocal, so that would be m is greater than 2 over epsilon. Okay, well, since m and n are both greater than n, then we can say that n, then we can choose n to be greater than 2 over epsilon. So now we can go back and we can write our proof. Alright, so now we can go back to here. And so we're going to write this as now we can write our formal proof. And so this will be sequence x sub n is a Cauchy sequence if for all epsilon greater than 0 there exists an n that is a element of the positive integers, and now we choose n to be greater than 2 over epsilon, where all n and m are elements of the set of natural numbers, and n is lowercase n is greater than uppercase n, and our sequence m is greater than our number that we choose uppercase N. And this implies that the absolute value of x sub n minus x sub m is all less than epsilon. Okay, so all we did is we took this and rewrite it to include n. Okay, so now this is the only thing that's new from what we started with. All right. Okay, so from here we can put in our 1 over n minus 1 over m again is less than epsilon, and then we can split that again like we did before in our scratch work. So this will be 1 over n plus negative 1 over m, and that's less than epsilon. Okay, so from here we can split it. So now we're going to apply the triangle theorem, and so that'll be this sum is less than 1 over n, absolute value of 1 over n plus the absolute value of a negative 1 over m. And we said before that we can make that positive, and we're going to go ahead and drop all of the absolute values since they're positive anyway. So this is 1 over n plus 1 over m. Okay, and so since n is lowercase n is greater than our number n, then we can say that 1 over n is less than, as a fraction, right, less than 1 over n. And since same thing for m, and since m is, our sequence m is greater than our uppercase n, then we can say that 1 over m is less than 1 over n. So from here we can replace 1 over n and 1 over m with 1 over n, because this is going to be less than 1 over n plus 1 over n. All this is going to be less than that. And since we said before, since we chose n to be greater than 2 over epsilon, then this is going to be less than this. So this is going to be, because this is n, this will be less than 1 over that, like we did over here. So this will be 1 over 2 over epsilon plus 1 over 2 over epsilon. And so from here, if we divide fractions, right, 1 over 2 over epsilon, we apply the reciprocal to the second term, so that's 1 times epsilon over 2. So we're multiplying the reciprocal here, right? And so that'll be epsilon over 2 plus epsilon over 2, 2. And all of that is equal to epsilon. So that shows that that proves that this x over n, x sub n minus x sub m is less than epsilon. Then x sub n minus x sub m is less than epsilon. So that means that our difference between x sub n and x sub m is within epsilon, and so it's showing that it's tending, after it goes past n, so it shows that it is in fact a Cauchy sequence. And that concludes our video.